Hello. So this is from the lesson today, which was on applications of quadratics, just in general applications. And so this problem in particular is about someone throwing a ball. It says Martin throws a ball straight up in the air. And it gave us this equation right here. Gives the height of the ball in feet t seconds after Martin releases it. And so whenever we're talking about throwing objects, you got to keep in mind that a thrown object follows a parabolic path. It's going to go up and then come back down. And so it says, from what height was the ball thrown? Well, in this case, again, we can imagine that we've got a person here. Martin. This is Martin. Looks a lot like Bob, but, Bob can have different names. So we're trying to figure out at what height, because he's obviously not throwing it from the ground, right? He has a height, his own height that he would throw the ball from. So we can imagine that as like right here. He throws the ball and it goes up. So we need to figure out how tall is Martin, basically, or from what height did he throw the ball. And then it says how many seconds before the ball Martin threw hits the ground. So we're looking for this time right here. How long was the ball in the air before it finally hit the ground? So we're looking for this point when our time is 0. What is our height when our time is 0? And then this one right here is what is our time when our height is 0? It's a little breakdown for you of what we're looking for. So to find the height the ball is thrown, we can actually just let t equal 0. When time is 0, what is the height of the ball? So we're just going to plug 0 into our equation. Everywhere we see a t, we'll replace with 0. And if you notice, this cancels out and this cancels out, because whenever you multiply by 0, you get 0. So the initial height that the ball was thrown at was 5 feet. Now to find how many seconds before it hits the ground, well, that one is going to be a height of 0. When it hits the ground, it is 0 feet above the ground. So this one we're going to set equal to 0, our equation, and we have to solve it. And we can use the quadratic formula for this. T in this case. T equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This is a recap. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. There's a song for you. So we could simplify this, and I really suggest using that graphing calculator or the calculator quadratic formula calculator link I sent you. Or another approach would be to just slap this bad boy into the Desmos graphing calculator. And you'll see here's my equation. I just used x instead of t. It doesn't really matter. I think it would still work if I used t as well, but I just default the x. And then if you look, you get this graph here. And we see this is where Martin is standing. Good job, Martin. Okay, so that's the answer we found initially. That's how high he was when he threw the ball, the height that he threw the ball from. And if we look over here, we can see, boom, this is where our ball landed. It is simply the x-intercept. And so the answer that makes sense here would be that it would take about 2.6 seconds for the ball to hit the ground. Graphing can save us a lot of time if we have that ability. But I just wanted to show that to y'all, and just so you know, here's the official graph that I did. And you can actually edit the settings over here so that it can fit more. So like if I wanted my y-axis to count by ones, I could do it like that. But I like it counting by 5s. I can make my x-axis count by 1s or 5s. And I can change how far it goes. Like if I only wanted to go from -1 to 7, I can tweak those so that I can see more of my graph. And I see, and up here, this would be future learning preview. This is actually the max, how high the ball would get. So after 1.25 seconds, our ball will reach a height of 30 feet. Just a little help here to help you solve these problems, maybe save you some time in the future.